Good morning. We are working on factoring today in 20-2, but this factoring is going to apply to anyone who needs to work on factoring. In a series of lessons in the next bit, we're going to talk about factoring as we've seen it all the way along in our education and how we can make use of it, particularly in 20-2, but also in the units of quadratics in both 20-1 and 20-2, in a whole bunch of polynomial work in 10C, and even in 9. Okay, so what kinds of things have we seen so far in factoring? Let's go as far back as grade 2. I hate to do this to you, but I'm going to. In grade 2, you may have memorized some of your math facts, and you may have had a teacher that said, let's explore what they mean. And so a rectangle like this, called an array, might have been in front of you. And what math fact does that represent? What idea does that represent? Anyone know? If we're talking multiplying? No? I'm going to tell you that it represents 3 times 2, or 2 times 3. And I'm going to tell you that we can also say that 3 and 6, 2 I mean, are factors of 6. Yes? Give me a smiley face if that's good. Yay. The other piece that this tells us is that if I wanted to do the area of a rectangle and the length was 3 and the width was 6, we could sub those in and do 3 times 6 equals, whoops, do 3 and 2, sorry about that. Three times 2 is equal to 6. So this is the fundamental piece on which we are going to build things that are going to go into radicals and things that are going to go into polynomial factoring. Okay? So just to know that we have it, let's express those very same ideas with a different fact. Let's go with 3 and 5. So I'll ask you each to write something. Adnan, can you write this picture I'm about to draw as a multiplication statement? Liam, can you state the factors of 15? And Ariana, can you talk in terms of area of this object that I've got here? So in the chat, or you could write it on the board. Probably in the chat is going to be best because you won't know where each other is writing. I guess I could give you a space. Adnan's got the space above that line. Liam's got the middle. And I think I did Adnan. And Ariana, you've got the lower space. So Liam, you've got the middle between those two lines, and Adnan, you can write on the top. So Adnan, you're going to write the math fact. Liam is going to write factors of 15. And Ariana is going to write an area fact. That's brilliant. You're writing just the multiplication fact. I'm going to write it for you because if I'm not clear, it's not your fault. Oh, looks like you're going. All right, good. Ooh, I like what you're doing there. 15 squares, nice. I like that. So what you're noticing is the object that you're counting there is actually changed. Here we're counting 5 lines of 1 unit long, 5 little toothpicks, if you will. These are toothpicks too. But suddenly, what Ariana is noticing is postage stamps. Oops. I'm going to draw little postage stamps in here. There are all these postage stamps kind of now covering area covers, whereas linear measurements are toothpicks, they're lengths, okay? So I've got 15 of those squares, and that's a length times a width. That's brilliant. I am going to just extend our thinking slightly and say, well, what if I added a row? Because you know what else these pictures talk about? These pictures talk about 3 columns of 2 things, 1, 2, 3, right? Or 2 rows of 3 things, 1, 2. Same thing down on the bottom. Can you give me a happy face if the rows and columns idea helps you or makes sense to you, rather? Okay, good. So now I'm going to put this +1 here, and that's interesting because the distributive property is about to get awoken. I know that you know how to add 3 plus 1, but let's pretend just for a minute that we don't. If we didn't, we could still use the fact of 3 times 2 is 6, and then we'd add this extra group of 2. We're distributing the 2 across the 3 and then across the 1 that's left. I could even change this to a 2. I'm going to put it over here. And when I put that piece on, the 2 that's here distributes across the 3 and distributes across the 2, and we end up with 5 times 2, right? I can even put a +1 down here, and what that does is it distributes across the 3, and it distributes across the 2, and we have the very same picture at the top than we have at the bottom. But we've created it in quadrants. I'm just going to, I may push you more than you're comfortable with at first, but just let's bear with me. I have the 3 times 2 piece, which is the 6. I have the 2 times 2 piece, which is a 4. I have the 1 times 3 piece, which is a 3, and the 1 times 2 piece, which is a 2. Let's just make sure you see where all those go. I'm going to use a highlighter to help with that. So here is 6. Here, oops, is 4. Here is the 3. And lastly, here is the 2. Can you give me a happy face if you followed how that grew? Okay, and now can you tell me in the chat, what's 6 plus 4 plus 3 plus 2? All these numbers at the top. What are they? What is that? No surprise, hey? 6 plus 4 plus 3 plus 2 is 15. This is 15, but we got to this a different way. We would never really work that hard to get 15, but there's this thing, and there's this thing called the distributive property. So I'd like to move us in our next video to another kind of array that's a bit more complex. So let's close this one, and I'll meet you in the next session, part 2.